Hi, I'm Mrs McTaggart and thanks for choosing to watch this video. I'm going to be showing you how to factorise using the process called a difference of two squares. Okay, so before I go on and actually show you what this is, I'm just going to talk to you about that heading, difference of two squares. Now in maths, a difference means a takeaway number, and if we say something is a square number, let's think of a really popular square number. Let's go with the number 16. That's a square number. And let me put a little letter here at the front. Let me do a squared. This is what a difference of two squares presents like. You've got a squared term here, which is a squared. And 16 is a squared term because 16 can also be written as 4 squared. So you have a squared letter, take away a squared number. That is a difference of two squares. Now, what I'm going to do is I'm just going to take you to a very simple question. And we're going to expand these brackets. Now when you multiply this out, a times a gives you a squared. A times minus 4 gives me minus 4a. 4 times a is plus 4a. And 4 times minus 4 gives me minus 16. Now if you tidy this up, those middle two become 0. So you're left with a squared minus 16. Now hopefully this looks familiar because I just did it up there. So what I've shown you is... I couldn't move the screen there, is that a squared minus 16 is the same as a minus 4, a plus 4. Now, that is what we're doing today. That's what I'm going to show you how to do, is to write something like a squared minus 16, a difference of two square terms, as a pair of brackets like that. Because factorising is all about putting an algebraic expression back into bracket form. So there is a kind of trick to it and people pick it up really, really quickly. If you've got two empty brackets, I always start with the empty brackets, and you think, right, with the first terms, what multiply together to give you a squared? Well, that must be a and a. The end terms, what multiplies together to give you 16? Well, 4 times 4 is 16. You could also just say what is the square root of that number. And then, so that they cancel out in the middle, one's got to be a plus, one's got to be a minus. So let's go do some actual examples, okay? So this is just a wee generic bit that I get pupils to write down, just to remind them that a square term minus a square term can go into two brackets where we take the square root of each term, one with a plus, one with a minus. So remember, this is just repeating what I've said. A difference of two squares is a squared term minus another squared term. So here are some examples. M squared minus 1. So my starting point is always, let's get your empty brackets written first. To get the m squared, well, that comes from m times m. The square root of 1, now 1 is really easily forgotten as being a square number. To get 1, that comes from the product of 1 times 1. And to get them to cancel out in the middle, so for the m terms to disappear, 1 has got to be a plus, 1 has got to be a minus. That's simple. And sometimes I might write those brackets the other way around. I might write m minus 1, m plus 1. And it's really important to remember that that's the exact same thing. You do have the same brackets here. It's a bit like 3 times 4 being the same as 4 times 3. They can be written either way around. So let's look at the next one. So we've got y squared minus 16, so open brackets. To get y squared, the first terms are y and y. The square root of 16 is 4, so we've got a 4 and a 4. One's got a plus, one's got a minus. So difference of two squares, honestly, pupils love it, but it does get a bit tricky. It's not always in the order of a letter take away a number. I've just filled you into that because that's what my examples have done so far. This time it's a number take away a letter. Do not change the order, okay? Keep it as it comes and follow the method I'm showing you. So the first term comes from doing the square root of 81. 81 comes from 9 times 9, so we put 9s at the front of the bracket. To get the x squared at the end, that means we've got an x times an x at the ends of the brackets. One's got a plus, one's got a minus. And if I accidentally wrote that and changed the order, for example, I quite often see people writing this. That is not the same thing, because if you multiply out this one here, x times negative x will give you negative x squared. But if you multiply out this one, it'll give you positive x squared. So changing the order does change things. So don't do it. Take it as the order it's given, okay? Let's look at these next ones. Just getting a wee bit more busier. So open brackets, think, right, what's the square root of 4? That's 2. And you've got a y squared, so your opening terms are 2y and 2y. To get 9, that comes from 3 times 3 with a z squared. So we've got a 3z and a 3z, 1 a plus, 1 a minus. And you might notice I put lines through my z's because they start to look really like 2s sometimes in algebra. So that there is probably the worst kind of one you can see right now at this stage. Just looks a wee bit busy, but the process is exact same. What is the square root of the first term? What is the square root of the second term? A couple more for you. So 16a squared minus 1, open brackets. Right, to get 16, that comes from the square root of 16 is 4, so it comes from 4a times 4a for your first terms. 1 is that sneaky square root again. 1 times 1 is 1. 1 with a plus, 1 with a minus. And then this is my second last one of this style. They do get harder. So I'm doing 2 lessons in one here on this video. Let's get the open brackets. Square root of 25 is 5. So you've got a 5m and a 5m. Square root of 36 is 6. So you've got a 6n and a 6n. 1 with a plus, 1 with a minus. So I hope you're following this and thinking this is not bad. So my last one before I start showing you the next style is this one. This always catches people out. We can hopefully recognise 36 as a square term. But what about m to the power 4? It is a square term, you just might not spot it straight away. So I know to get the 36 comes from a 6 and a minus 6. But how do you get m4? So this is really easy if you can recognise that m squared times m squared would give you m to the power 4. So this is a wee sneaky one. So my first term is actually an m squared. So these have been what I call the straightforward difference of two squares. Obviously we can make things a wee bit more difficult. So sometimes the difference of two squares is not obvious until we remove a common factor first. How do they make a question harder in your exam? They combine the two processes. And the clue to these ones sometimes is it says factorise fully before the question. And it's also worth more marks. Your difference of two squares is only worth about a mark. Factorise fully is worth 2 marks, alright? So, and this whole factorise fully maybe thinks there's a wee bit more to it. So, in any factorising, the first thing we have to look for is the first thing we taught you, which is common factor. So if you look at 2a squared minus 18, they both divide by 2. So if I do 2 bracket, if I divide both of these by 2, I'm left with a squared minus 9. So I've taken out my common factor correctly, but wait a minute, that bit in the bracket, do you recognise that as a difference of two squares? You've got a square letter, take away a square number. So this can go further. So the 2 is a common factor that just stays out the front this time. And then I put my open brackets out. A squared comes from a times a. And 9 comes from 3 times 3. So I've got a 3 and a minus 3 in my brackets. Now, do not try and go straight from your question to that answer. If you get it correct, fair enough, you'll get full marks. But in my years of marking, the people who try and jump straight to the final answer mess up. And let me show you what they write all the time. So this is what we see very often as a wrong answer here. People who skip will go straight from there to there, which is wrong. A quick glance at this, 9 times 9 at the end gives me 81, then 81 times 2 is 162. I didn't have 162 in my starting question, but as a marker I can look at that and say, oh, they've known there's a common factor of 2, and they've done 18 divided by 2, but they haven't dealt with the square number 9 and square root in the 9. So if you do this in your exam, you're going to get 0. So please be safe, put in the 2 steps of working. My general consensus is, well, it's worth 2 marks, so there's 2 steps to it. So 2 lines of working with your answer. So let's look at my next one. Okay, so 75 minus 3x squared. Now, it might not jump out at you straight away, but 75 does divide by 3. This also helps if you really know your square numbers. But I know 3 divides by 3, so there's a good chance 75 does. and it does, it's 25. 3 into 75 is 25, which is brilliant. It's a square number. Take away 3 divided by 3 is 1, so I've got 1x squared, but of course, remember, we don't write the number 1. That bit in the bracket is now a difference of 2 squares. So keep your common factor 3 at the front. Open your brackets. Square root of 25 is 5, so 5 and 5 at the front. X squared comes from a plus x and a minus x. So there's that one. 2 lines of working. And just to finish off, let's do 2 more. So just a reminder, this would be obviously the second lesson on difference of 2 squares. You'd have the basic ones, get some practice, and then you come back and do these ones with common factor. So 20 and 45, clearly divide by 5. And if you divide by 5, that leaves you with 4p squared, a nice squared term. Take away 9q squared. So there we've got a difference of 2 squares again. So you have 5, pair of brackets, 4p squared, well, square root of 4 is 2, so you've got 2p and 2p at the start. Square root of 9 is 3, so you've got a 3q and a 3q, one with a plus, one with a minus. So that's just one of those busy looking ones. And then my very last one is probably the hardest I think you could ever be asked. It's got a number and a letter common factor. They both divide by 8 and they both have a y. And when I remove the 8y, 32 divided by 8 is 4. Y cubed divided by y, remember your y cubed looks like this. And if you square out the y, you're left with y squared. 8y divided by 8y is just 1. And remember, this one is not always an obvious difference of 2 squares because people forget that 1 is a square number. But it is. So pair of brackets, squeeze this in here. 4y squared comes from 2y times 2y. 1 comes from a plus 1 and a minus 1. Now, just to show you, if I quickly just changed that question for a second and made it 32y cubed plus 8y, that would give you a common factor of 8y. That would leave you a y squared plus 1. Is this now a difference of 2 squares? The answer is no. And I catch my pupils out all the time doing this. Now, this is my last example. And they go, oh, squared thing. Yeah, difference of 2 squares. Remember what difference means. Difference means it has to be a takeaway in here, okay? So you cannot then go any further with what I just had there if it had a plus. It's got to be a square term, take away a square term. Anyway, thanks for watching. That's an awful lot I've done in this video. I hope it's helped. Bye-bye.